Alright, number 1, this is the 5.3c homework. They want you to find the real or imaginary solutions. So this one over here, we're going to look at it and determine that it's a sum of perfect cubes. So it's going to be in the form of a cubed plus b cubed. So let's write down the way that that's factored. It's a plus b times a squared minus ab plus b squared. So we need to figure out what our a and b is. So let's rewrite this. It's going to be x cubed plus 4 cubed, because 4 cubed is 64. So our a is x, our b is 4. So we're going to have x plus 4 times x squared minus ab, so 4x, then plus b squared, which is 16. This is going to give us a solution of negative 4. This over here is going to give us two solutions because it's squared, but we're going to have to put this in quadratic form, or put it into the quadratic formula. So the opposite of b plus or minus square root of b squared minus 4ac all over 2a. So we're going to have 4 plus or minus, this is 16, so 16 minus 16 times 4 is 64. So 16 minus 64 is negative 48, all divided by 2. Let's simplify this by taking the I out of it. And now let's break down root 48. So root 48 is the same as root 16 times root 3. Root 16 is the same as 4. So 4 root 3. So 4 plus or minus 4i root 3, don't forget the I here, all divided by 2. We can simplify 4, 2, and 4 by dividing each of those by 2. So we're going to have 2 plus 2i root 3 and 2 minus 2i root 3. So here are your three solutions. Alright, this one over here is a lot like the other one, but it's a difference of perfect cubes. So it's a cubed minus b cubed. That factors as a minus b times a squared plus ab plus b squared. So let's rewrite this in this form. So it's going to be x cubed minus 3 cubed. A minus b is going to be x minus 3. A squared is x squared plus a times b, that would be 3x, plus b squared, that's going to be 9. This gives us 3 as a solution. This will give us two solutions, but we have to use the quadratic formula again. So the opposite of b plus or minus square root of b squared minus 4ac all over 2a. So let's simplify this. We're going to have negative 3 plus or minus the square root. This is 9. 9 minus 36 is negative 27, all divided by 2. So if I extract the negative out, I'm going to have negative 3 plus or minus I root 27 all over 2. Let's break root 27 down. That's the square root of 9 times the square root of 3. The square root of 9 is 3, so 3 root 3. So negative 3 plus or minus 3I root 3 all over 2. You can't cancel anything here. So we're going to have negative 3 plus 3I root 3 all over 2 and negative 3 minus 3I root 3 all over 2. So these are your three solutions. All right, number 3, they want you to graph this and find the solutions. So let's plug that in first. So 4x cubed minus 8x squared plus 4x. Let's get an idea of what it looks like first. Alright, so we need to find the zeros here. So let's first look at our table. See if there's any points that we can plot on here. So the first point is 0, 0, the second point 1, 0. Two comma 8 is another point that we can plot. And that's pretty much it. What I'm going to do now is I'm going to zoom in on here just to see if there's any local max or mins. So I'm going to do a zoom box. Just right in here. Just to see what it looks like. Alright, so it looks like it's bouncing off the graph at 1. Which makes sense, because then that would mean that this is a double root, and this would be a single root, because it goes right through. So your roots would be 1, 1, and 0. That gives you 3 roots, and it's a cubic, so that makes sense. So we can plot this point here. First, let's find out where it is. So it's a local maximum. So go to the left of it, to the right of it, and then enter. So 0.33 comma 0.6. So this is where it kind of tops off, right there. And it bounces off of here, and it goes up. So let's try to graph that as best as we can here. So it goes up, through, bounces off, and then goes up the rest of the way. And then down here. So the zeros are going to be 0 and 1. And 1 is going to be a double root. So it has a multiplicity of 2. Alright, this one over here they want you to factor. So let's first write this all on one side. And then put the parentheses. There's no GCF, it's in order, so we're good to go. So we're going to have an x squared and an x squared. Two numbers that multiply to give you negative 18, but add up to a positive 7. That's going to be a 9 and a 2. A positive and negative. Now we're going to set these up equal to 0. Subtract 9. Square root both sides. Extract the negative. And then root 9 is 3. So positive, negative 3i. Those are two of the solutions. This one over here, do the same thing. Set it equal to 0. Add the 2 over. And take the square root of both sides. So your zeros are going to be positive 3i, negative 3i, positive root 2, and negative root 2. All right, we have another graphing problem. Let's get the window back here. Let's clear this one out and then type in x cubed minus x squared minus 16x, and then we're going to move the 20 over, so minus 20. Let's get an idea of what it looks like. Alright, well it looks like it bounces off here like around negative 2. We can consult the table. So that looks like it's a double root. And then we have a single root here. It looks like it's 3, 4, at 5. So it looks like negative 2 and 5 are your roots, but we can look at the table in a minute. And it looks like it's going to go all the way down here. But we don't really need to know how far it goes down because it's not asking us about the relative min or the turning points or anything like that. So let's look at the table. And let's plot some points, the ones that we can plot. So negative 3, negative 8. Let's plot that. And then negative 2, 0 is another point. Negative 1, negative 6. Let's see. 5, 0 is another one. Let's take a look at our graph again. So it's going to go through this point, bounce off of 2, come down, go through this point, and then we're going to have a dotted line here, and it's going to come up through this point all the way up. So let's try to draw that. Up, bounce, down, and then all the way up. So this probably should have been a little bit more steep here, but it's close enough. So the zeros are going to be negative 2 and 5, and this is a double root as a multiplicity of 2 because it bounces off. Another one where we have to graph. So let's take this out. So x cubed minus 3x squared plus 4. Let's take a look at it. Alright, again we have a whole bunch of multiplicities that are even. Bounces off here and it goes through here. So that's going to be 2 roots here and 1 here to give us 3. So let's see if we can get some points to plot here. Alright, so it looks like negative 1, 0 is going to be my first point that I can plot, and 0, 4. One comma 2 and 2 comma 0. 3 comma 4. Let's just take a look at the graph now. We know it bounces off here, so that means that that's going to be our 0. Let's just see if this, it looks like it tops off exactly at that point, but we can use second trace max just to make sure. Left of it, right of it, and then enter. Yeah, so see how the e to the negative 7, that's really close to 0. So 0, 4 is where it tops off. So that's your local max. That's your local min. So it's going to go up through this point, top off here, go down, bounce off the graph, and then go right back up. Let's see if we can draw that. And your zeros are negative 1 and 2. They want you to rewrite it in factored form. So this comes from x plus 1. Now remember, this is a double root. This 2 shows up twice. So instead of just writing x minus 2, we're going to write it x minus 2 squared because it shows up twice. All right, write in factored form. So it's in order. There's no GCF. So let's use the box method. We have 8x squared, a minus 3. Our AC is 24. Let's write down the combinations. Different signs, the larger one is negative. The one that adds to negative 10 is this one. So we're going to have a positive 2x and a negative 12x. So let's go around and assign the signs. And then factor 3, 2x, 4x, and 1. So 4x plus 1 times 2x minus 3. That's in factored form. Number 8, solve by factoring. All right, this is in order, and it doesn't have a GCF. So again, we're going to use the box method. So we have 3x squared, negative 5. We're going to have 15. We know the difference is going to be 2, so we'll just use 3 and 5. Different signs, the larger one is negative. So we have a 3x and a negative 5x. Let's go around for the signs, and then factor 5, 3x, x, and 1. So we're going to have 3x minus 5 times x plus 1 equals 0. This gives you a solution of 5/3. This gives you a solution of negative 1. Those are your two solutions. All right, this one we're going to evaluate by substituting. So 3 times y minus 2. If y is negative 1, negative 1 minus 2 is negative 3. Negative 1 minus 1 is negative 2. So negative 1 times x minus 1. If x is 4, 4 minus 1 is 3. And then times x again, which is 4. Negative 3 times negative 2 is 6. 6 times 3 is 18. 4 times 3 is 12. 12 times negative 1 is negative 12. 6 goes into both of those. 6 goes into 18 3 times. It goes into 12 2 times. And we keep the negative. So that's your answer. And number 10, explain why there's a special rule for factoring a difference of squares but not a sum of squares. Alright, so let's just take a look at what a sum of squares might look like. For example, x squared plus 25. This is a perfect square. That's a perfect square. There's a sum. It's asking, why isn't there a special rule for factoring? Well, try to factor it. See what happens. To get the x squared, you get x and x. What's the only way to get 25? Well, there's a couple different ways, actually. There's not an only way. It's 1 times 25 or 5 times 5. But the problem is, if I write down 5 and 5, what signs am I going to write down? Because the multiplication of 5 and 5 needs to give me positive 25. So it's either x plus 5, or x minus 5, x minus 5. If I multiply those out, I am going to get a middle term. The middle term is not going to cancel. This one over here, if you FOIL it out, equals this. This one down here equals that. You're going to get a middle term. The only way for the middle term to cancel out is if these two are conjugates. Another way to look at it is actually show that middle term, plus 0x. What does that mean? That means that you need to find two numbers that multiply to give you 25. So let's look at the possibilities. We already talked about this. Multiply to give you 25, but add up to give you 0, with both signs being positive. How is that possible? You're either going to get 10 or you're going to get 26. There's no way that's going to happen. So that means it's prime. If there was a minus sign here, then this says both signs are different. The larger one is positive, or one of them is positive, then you could use this one over here, positive 5, negative 5, and it would add up to 0. So then it would be x plus 5, x minus 5, and those are conjugates. So, in a nutshell, there's not a rule for the sum of squares, because once you factor out the GCF from a sum of squares, the sum of squares is prime. That's the reason why it's not factorable. You can't have a special rule for factoring if it's not factorable over the set of real numbers. This is factorable over the set of imaginary numbers or complex numbers, because if you solve for x, you get positive or negative 5i. So technically you could write x plus 5i times x minus 5i. That's factorable. But again, it's over the set of imaginary numbers or complex numbers.